Oh, Chris, very inspiring talk there. Actually make me feel quite old now that I remember actually physically drafting on the likes of Mylar, using rotary rings, trying to communicate using old brick cell phones. And I feel very, very fortunate that my career has enabled me to be sitting on the cutting edge of technology as we create sensors, software solutions, and partnerships that enable us to evoke smart change. What I'd like to do is to kind of give you a bit of an overview of the company that I work for. So I work for Leica Geosystems, and Leica Geosystems is part of the Hexagon Group. By definition, we look at the Hexagon Group as really being an information technology company. We strive ourselves always to push boundaries. We're in a societal environment that is constantly changing and changing faster than sometimes we like to accept. So the challenge for companies like us is to bring forth innovative solutions and create disruption to enable that our society and environments can be more tolerable to live in. What's interesting about the company is that we're not as big as GE. So we employ about 16,000 people worldwide. We have representation in 45 countries. We turn over revenue of about $3.5 billion, and our latest ambitions now will to be strive past $5 billion over the next three years. So it's an exciting time for us. Our revenue split is pretty much, if you look at the three main areas of the globe, where we look at the Americas, we look at EMEA, and then we look at the Asia-Pac region, it's pretty much 30-30-30 in the most simplistic manner. What's most exciting about working for a company such as Leica Geosystems within the Hexagon Group is the way we look forth at taking sensor technology and software and fusing them together. Fusing that information together to create what we call digital reality. And that digital reality then is looking at our real world and mapping it into a digital world in such a way that the information that we're extracting from that digital world is not just data. I like to think of it more as information. It's intelligent information. It's information that becomes very, very rich that we can use in every aspect of what we do. But this intelligent information suddenly becomes very, very actionable. It means that we can use that information to make fast decisions that ultimately can impact a lot of the things that we do on a daily basis. The company kind of really serves two main application areas. We have on the left side the geospatial enterprise group of businesses, on the right-hand side the industrial enterprise solutions. I really focus my world, or where I've come from, is really on the left-hand side. And we're pretty much 50-50. What's exciting within this is the geospatial enterprise group is really divided into 6 businesses that serve various different segments. We have the Geosystems group, our positioning intelligence group, agriculture, our geospatial, our mining, and our safety and infrastructure. In the last 24 years, which is kind of interesting that I've worked for Leica Geosystems and watched the evolution of a lot of the sensors that we design and build, they touch each of these businesses. And each of these businesses, in turn, touch multiple segments. If I look at this, really the core of where I've come from and what I represent is really the survey engineering, infrastructure, and construction side of the business. And that represents about 35% of the revenue that comes out of the geospatial group at the moment. We have a huge history. And it goes back to the early 1900s where we started developing sensors. And I think Chris, that was just speaking from Arup, could probably put his hand up and he'll remember one of the original airborne mapping systems and the kind of first, what we now call total station for point positioning, which was the old T2. Fortunately, I've seen a lot of evolution in these technologies over the years, where now we're building systems to kind of capture reality, not only from the air, but on the ground, and even now as we venture into the world of underground surveying through the implementation of radar. What's interesting is all these different solutions work together in some form or other to really create this digital reality world. And what we're doing now as an organization is evolving more and more and more to taking these sensors coupled with software and know-how and serving them up to different segments to solve and shape change as the future evolves around us. I love this picture because the world I work in is about creating disruptive technologies. And this picture is taken from 1925. If you imagine, how did you create maps prior to airborne mapping? It was all done on the ground, hugely laborious. I'm sure, Chris, you probably have some fantastic pictures of people traipsing through the heart of Africa to create control networks and everything. I like to think of this guy as very disruptive in what he used to do. He was also extremely brave and fearless because he had to fly in that biplane that probably didn't have the reliability that GE implement in the engines that we use every day to travel around the country. And he had to hang out the side with a camera that probably weighed 30, 40 pounds and take pictures. So I like to think of this guy as being hugely disruptive in what he has done. And then set forth, a path for a company like Leica Geosystems to enter into the world of mapping. Let's fast forward from 1920 to the late 1980s. Because I always like to think then surveyors are always adopting new technology, always looking to embrace things that can make things more efficient, more productive, and realize gains. The guy in this picture, I also like to think is quite disruptive. Why? So this picture is actually of me. I have to take my word from it, because that's my arm sticking out the front window of the car in the northern part of Saudi Arabia in 1989. What was brilliant about this is that we were using some of the first commercially available GPS units, not only for just navigation, but also we were using it to position villages, wells, infrastructure. And what I mean by infrastructure back then was telephone poles carrying wires across the desert to feed into what we believed was going to be the start of a GIS system. What was interesting on this was we only ever had satellite coverage back in 1989 in this part of the world for about 5 hours a day, which potentially meant that we were lost for the rest of the time when we were out there. And it was interesting is that one of the big learnings that I had when you kind of think of where we were, if we were lost, how did we find our way? Well, you didn't really worry about it. Again, I was 21 years old back then. I didn't really care whether I was lost. I felt like David Attenborough in the middle of nowhere, seeing things that most people probably have never, ever seen. But I always had confidence that the technology was there behind us to keep us moving forward. Is that I knew that when the GPS wasn't available to give us a position as to where we were, so I could plot it on a paper map to understand exactly where we were, that at some point in time in the short-term future, the GPS would become available for me to get a position. So I always had the confidence. The one thing that I always lacked a bit of confidence, because they were early generation systems, is you didn't know actually if they were going to work. So it was always the problem that if the cable broke and it didn't plug in or you couldn't get power to it, that you wouldn't get a position. So I like to think that the crew I worked with in those days, that the company I worked for that was doing this work in Saudi Arabia were very, very disruptive in what they were trying to accomplish with the technology. When I first moved to the United States back in 1994, I always felt that the world was my oyster. I was honored to be able to come here to the United States and start my career off working. I always felt it was the land that was going to create the large opportunity for me. And it has. I have no regrets whatsoever. And I met a professor at the Colorado School of Mines when I was in Denver. And he once turned around to me as I introduced myself to him as a surveyor. And he quoted to me somebody, and I can't remember his name, but it was from National Geographic. And he made the comment that a map is like an epic poem. Its lines and its realization of color is our reality. And I love this. Absolutely love it. Because we use maps every single day. Some more than others. So for example, I'm not staying at this hotel. I'm staying down the street, but I don't know downtown San Francisco. What did I do? Pulled out Google Maps, put in 2 locations, and away I went. Told me exactly how long it was going to take me to walk uphill to actually get here. I don't like walking uphill on that. But maps are not what they used to be. Maps today offer, again, rich and intelligent information. When I open up a map, it's a visualization of reality around me. But when I start adding information into that, it becomes rich. I can make decisions. When I opened up my Google Maps today to find my way from one hotel to the other, I could make a decision. What's the quickest way to go? What site do I want to see on the actual way? The map is informing me and helping me make decisions at all times going forward. So what about today? So Leica Geosystems as a company has been in the airborne mapping business and now evolving into an organization that is creating digital realities. And we have to recognize that the world of UAVs is an extremely important part of our business and will be an extremely important part of our business. So I'll share with you 2 examples with 2 customers in different parts of the world that have employed UAVs to accomplish their tasks. The first one was a project where they were asked to survey an entire island. It's actually St. Michael's Mount off the south coast of Cornwall in the United Kingdom. And the task at hand was to create a 3D model of this entire island, including the small village. Part of it was for historical records. Part of it was really to update, the change that's happened to the island over the years. Not a huge project. It's probably about, quarter of a square kilometer in size. So not a big task. But then I look at it. If you look at it overview, it looks quite simple. As you look at this angle here from the side, and you see the amount of trees, and then you look at the task and the specifications that was asked, it was like create a 3D model. So that meant inside surveying as well. So all the details from not only the outside, but the inside had to be done. This meant the company that was deployed to do this particular project had to employ quite a lot of different technologies. So they decided they were going to employ traditional land surveying equipment, such as total stations and GPS. That's what most people would do to do this type of project. To employ LiDAR systems, or high-definition scanning systems, to capture more detail, but then to deploy UAVs to kind of augment some of the details that were captured from scanners used inside to traditional equipment. What I love about this was that they were able to document the realized gains that they had through employing UAVs and integrating it into their actual workflow. And I simply represent this, that the way they viewed it and the way they summarized it was that running the UAV surveying component with traditional surveying techniques, they were able to calculate that they realized a 60% time savings on accomplishing the task as compared to taking it on fully using conventional surveying method. So from this type of an organization, the message we send out is that as we look forward into the future of surveying or into the future of geospatial capture, it's inevitable that everybody will have to deploy some sort of drone mapping system to compete as the world evolves forward. This is a second example that I use. And again, at first you look at it and you're going to go, well, it's a black and white map on one side and a color map on the other side. The story behind this is a construction company, which are one of the largest in the United States. We're working on the construction of a new hospital down in Florida. Make sure I get it the right way around. On the right-hand side, no, sorry, the left. Yeah, let's do it that way. On the left is just basically a typical 2D representation of what the project should look like when it's finished. So therefore, you see the building outlines, you see the contours. So it's really a 2D representation of what design should be. One of the big things they had on this project was a huge amount of earthworks. So a lot of dirt had to be moved from one spot to the other. So this organization decided to deploy a drone mapping system, and I believe it was a DJI system, to basically fly the project area on periodical times. So as the Earth was moving, they deployed these drones, captured the information, fed it into some mapping software to create 3D models of what was actually going on at that point in time. And then all they did is graphically and visually represented it as an elevation heat map. So obviously, the darker the color, the lower the elevation, the higher the color, the higher the elevation. So that meant that the project managers instantaneously could get a view of what progress was being made in terms of the earthworks that was going on. So how much dirt had been moved? How much dirt had yet to be moved? Are they on schedule and are they not? The realized savings by deploying the drone to kind of give them the results on a regular basis like this, attributed to 3 days of 3 survey crews being deployed at each instant in time that they had to produce that according to the actual schedule. So one of the things that we're seeing is we're seeing our customers adopt the technology. Customers within our field of traditional surveying willing to take the step into new technology and deploy it to realize some quite fantastic gains. And these were just 2 examples. So looking forward, I've seen a lot of change go on in my industry. I kind of felt embarrassed that I actually knew what it was like to use a rotring ink pen and decide, should I use a 0.2 mil, 0.5 mil, or I get very excited if I had to use the big thick one. So I've seen a lot of change go on. And one of the things that I've noticed is that the world of UAVs has grown so fast that it's hard to wrap my head around. And I just represent here that I know of the number of companies that are producing UAVs at the moment. I think earlier in one of the keynotes this morning, they talked about 450 companies, are now deploying, utilizing, developing on, et cetera, on actual drones. So it's become a very crowded place in a very, very short period of time. So 2 to 3 years ago, Leica Geosystems, which has been recognized as a leader in the world of airborne mapping systems, and we kind of develop aerial cameras, both optically, digitally, and LiDAR-based, recognized in stages that we can't walk away from the world of drone mapping. So that's why we made the acquisition of Abotics. So that enabled us to stay connected into the world of, let's call it, mobile mapping. But we realized very, very quickly that as a company, we weren't going to compete in this particular space. What we had to do is find our own identity within that space and start creating that. So again, to use the term, I think was stolen by GE, is that we coined the phrase the flying sensor. And this flying sensor comes to reality to serve the need of what we believe our customers are, to realize our dreams of creating digital realities is going to be through partnerships where we collaborate on know-how and bring the best of both worlds together to create what we call a flying sensor. So hence, we had this partnership that was announced between Leica Geosystems and DJI back in October, which will enable us to bring, as I say there, the know-how of 2 companies together. DJI from the strength and knowledge they have in terms of airborne-based systems, the strength and knowledge from a company like Leica Geosystems in terms of sensor technology, and then coming together to create the right segment solutions that will afford this smart change as we go forth. So what do I mean by a flying sensor? So this is just my interpretation of what it actually is. So I look at it kind of just, let me just put some things that Leica Geosystems is able to bring to the table in terms of its knowledge base, linking it together with a UAV. I use the term Augmented Gnss. So a lot of us are familiar, we use the term GPS, Global Positioning Systems. GNSS is Global Navigation Satellite Systems, because we're not dealing with just the American-based system, We're dealing with GLONASS, which is the Russian-based system. We're dealing with Galileo, which is the European-based system. And we're dealing with Baidu, which is the Chinese-based systems. So in the period that I sat in Saudi Arabia tracking 4 or 5 satellites for a 4 or 5 hour window, we're now forward wind 20 years dealing with multi-constellations. And now we're augmenting that further with geostationary satellite-based systems, so that now we're starting to enter into a world where we start talking about RTK, which is solely dependent on base stations broadcasting corrections so that you can derive your position, to now talking about standalone point positioning systems. So you're augmenting the GNSS to give you an autonomous position down at the sub-decimeter level. Obviously imagery, obviously thermal, obviously multispectral. But the two exciting worlds that I see is the introduction of SLAM technology, or self-locating automated mapping systems. I was going to show a video that Benjamin had very kindly, Benjamin I see you there somewhere, very kindly shared for me. This is not the video at the moment. And what it showed was a DJI unit flying in the lobby of a hotel. Lobby of a university. And when you first watch it, it was about 45 seconds of this unit just stationary and just flying stationary, not moving. And I sat there, and Benjamin, unfortunately, did not send to me an explanation of what it was. So I sat there and went, this is probably one of the most boring videos I've ever watched. It was a drone hovering in the lobby of a school. After a little bit, I realized when I started noticing that it was just moving, rotating slightly, every couple of 10 seconds, that it actually was employing SLAM technology, which basically meant this unit was not only flying autonomously, but it was sensing what was going on around it so it didn't move. And then at the same time, it was taking imagery of those particular pictures. I think I've lost Liz. So that's how boring the video actually was to watch, is what you're seeing on that screen, to be honest. That's the Irish humor that comes out of me on that side of it. Okay, so the other exciting technology that was coming out is the world of LiDAR, is the ability to capture point clouds. And I know we saw this a little bit earlier on. Leica Geosystems as a company has been involved at the forefront of point cloud generation. So we were one of the first companies to bring commercial scanning systems to date. If I get it back, I'll hopefully be able to show something at the moment. Today's terrestrial scanning systems are typically, about yay big. You can fit them within my arms this way, okay? And they weigh about 20 pounds or thereabouts. And they rotate and scan and pick up 1 million points a second. It's unbelievable. When I look back of where it first started, we were talking 2,500 points a second. These things capture 1 million points a second. That means a good quality scan can look like a high-res black and white image. Now, if I put cameras in there and et cetera, and start draping the imagery over the actual point cloud, then you end up with these incredible imagery that has got geometric correctness associated with them. At Autodesk University last week is that we announced a new product which we call the Black 360. And the Black 360 has basically taken this scanner that I said that fits in here and reduced it inside with near same capabilities to something that's 2.2 pounds in weight, is scanning at 360,000 points a second, has 3 15-megapixel cameras, it's got LED flash support, HDR, and has got one-button operation. And one of the things that I heard that came out of the conference, which was an incredibly proud moment, is that Leica Geosystems has created for the world of scanning what the iPhone has done for the world of portable phone technology. But what's interesting is that the reason I put this in is it's completely disruptive technology. Is that this disruptive technology enables us to think forward, that if I can take point cloud-based products, or point cloud generation products, and reduce them into something that's 2.2 pounds in size, then maybe I have the capability of looking at how I can attach this type of technology onto drones and enable us to fly where we can capture reality and generate very, very rich point clouds on that. I'm going to flick forward on my slide. What enables us, and the point that I really wanted to bring this up, is because we've created disruptive technology, what makes it happen is that a company like Leica that's evolving has recognized to be successful in something like this is to partner with the right people. So therefore, in this case, we've partnered with Autodesk. Autodesk are one of the biggest providers of software into the AEC space. BIM is obviously, the new term in the world of construction. So designing and building in 3D. So therefore, taking a device such as this on the left, maybe I can go back one slide. Yes, that's my friend. So that's what I talked about, that's our traditional scanning business. The Scan P40, professional unit, still will be. But you can see the dimensions. And what we reduced it is to something slightly bigger than what you're holding in your pocket, which is an iPhone 6. Now bear in mind, that's a 2D picture. It doesn't mean it's as thin as an iPhone 6 because it's circular. But it's Autodesk that will allow the success of this product to happen. So therefore, we will control multiple devices on a construction site, for example. So I can capture all the imagery, all the point clouds, feed it up into the cloud, and then deploy it down into the actual office. So it's again, the point here is that we've created disruptive technology, partnered with the right people to afford smart change going forward. So therefore, I see, us kind of following that same thought process going forward, is that with partnerships such as with DJI, is now I could deploy some of our smart technology with their smarts and know-hows, deploy a true mapping system that can afford change based on what people's expectations are, and push it into the actual cloud. We all talk about pushing the cloud. I like that GE reminded us that all this information is easy to say push it into the cloud till we realize how we actually push it with the wireless bandwidth, et cetera, and the infrastructure there to be able to do it. We forget about that sometimes. We still kind of realize that there is internet outages. It happens and you shut down. Oh my God, the other day my cable went out at home. Myself, my wife, and my daughters sat there for 4 hours and didn't know what to do. We had nothing. It was just crazy. I had no TV, no internet, no smartphone, no nothing. We played a board game, and we were all bored doing that. And as soon as it came back on, everybody just reconnected and just went on and did their things. I want you to remember this one just a second as I go forward one slide, about this concept of digital reality. Because I love this picture. This is a picture of a partner, of us working with a partner. The company's called Gameco. So Gameco are one of the leaders in the creation of concrete paving systems. And this is one of the biggest concrete paver systems in the world. And the way the process works is that the concrete trucks roll up in the front of it, and this thing is constantly moving, very, very slowly. And they just pour the concrete in, and that kind of churns through the actual machine, and then all these sensors on the actual machine compared to what the design should be. And if you look in the far corner, I think if it's not shown, there's a picture of one of our robotic total stations that actually guides the entire machine. We use 3 of them to position it, and it pumps out the finished surface at the back. And I look at this picture and I look at how are UAVs going to fit into this world of horizontal construction going forward? And the way I look at it is that look at the traffic around, so from safety purposes. So what's going forward? What's happening behind? So I can deploy a UAV just to get an overview and create contextual information about what's going on as I'm driving this productivity. One of the areas that I'm more excited about is being able to deploy a UAV from what's been just poured. Because one of the interesting things is these type of contractors when they're pouring interstate sections like this, they're working on very, very big projects that cost a huge amount of money. These guys have huge amounts of money tied up, in this example here, in Georgia, with the state of Georgia, to ensure that they do their project on time and correctly. So the quicker they can release that bonded money, the quicker then helps fuel their own cash flow. So one of the things to get that money out of bond and back into their pockets is that they have to prove that what they've poured behind them is correct, that there's writability, parameters that are actually met. And I foresee one day maybe we're going to deploy a drone that's utilizing a LiDAR system that knows through planning exactly where it has to fly, collect the information, feed it to the cloud, and therefore then drop it back in such a way you have a picture of reality, but you've got a digital record of what you've done, and hence the bond gets free. In the BIM world, we have structures like this. I read a statistic recently when you compare renovation projects compared to new construction. There's quite a balance between them. So how do I capture information both in and out of structures like this and ensure that I capture all the right detail so that I can be as accurate in my design and deployment on a project? This is where we'll start utilizing drones, but utilizing technologies such as SLAM, because I can't use GNSS inside, using LiDAR systems coupled with imagery to kind of create this digital reality of what's going on before it goes to design. This one I love, because we talk a lot about rail. But then you question yourself as, how do I survey an existing tunnel? And if you just read recently, I think in Switzerland they've opened now the longest rail tunnel in the world. I mean, this thing takes about an hour and a half to go through on a train. It's huge. It's unbelievable on that. But at some stage in the future, somebody's going to have to do an as-built survey of what that tunnel actually is. Today, what we'll end up doing is having a guy on a cart using a LiDAR system, and he pushes it down the rail. But that's kind of efficient for today. But eventually, it'll be inefficient because of the time it takes to walk that cart or to drive that cart down through that tunnel. I foresee one day that we'll just deploy a drone down that particular tunnel. And that drone, through knowing where centerline is, because of the design parameters, will just fly along that particular path, know where it is because it's able to sense the sides of the tunnel, deploy the imagery devices, and deploy the LiDAR systems to create a true 3D model of that unit. So I see Leica Geosystems as part of Hexagon. Its future will evolve like this in the world of drones. On the left-hand side, we will continue to service our existing customer base. Our existing customer base will expect us to deploy airborne-based systems and a drone solution. That's what's expected of us. So we will, in effect, take care and shape. But we can't be all to everybody. So therefore, we have to build the blocks across this gap, which means bringing mapping-based technology to everybody. And we'll do this through connecting, collaborating, and forming partnerships. And that's why I'm so excited that Leica Geosystems has partnered with DJI, who are a leader in their world, to enable us to advance our particular world. And I have envisioned that when I started off with my good friend hanging out the side of the plane in 1925, taking a picture to create a map, is that who would have believed we have got to a stage where we'd be believing that so many people would be wanting to deploy drones. And it's my envision that the person on that construction slide that I showed you with Gameco, so everybody that's using and wearing, everybody that was wearing a yellow vest is going to be somebody that has the capability on a construction type project to deploy a drone to be able to capture this rich, intelligent information to speed up our decision making and hence afford change. So with that, I thank you very much for your time and your attention.